All right. Yeah. So I've been wanting to do that gone for a few hours now. Yeah. But yeah, welcome everyone. And this is going to be a workshop on debugging. And yeah, I'd like to share kind of why I think debugging is such a useful skill to have as a researcher, right? Um, has anyone ever used compiled languages before? So I'm thinking like C, C++, Fortran. Yeah, show of hands, nice. Has anyone ever run a program that's had a bug in it? Yeah, good show of hands. Yeah, Joe's only runs perfect code at the back. Must be written by yourself, Joe. That's why it doesn't have bugs. So I'm sure we've all hit bugs at various times in our careers. Either software you've written yourself or software you've used from someone else. And sometimes you're just not sure why it doesn't work. So today we're going to look at how we find that out. Welcome. So we're going to be covering the essential basics of debugging, the 5 Ds of debugging. We'll go across those. So what is a debugger? Well, a debugger is a program, a special kind of program that can be used to test slash debug another target program, okay? And via the debugger, the user can inspect resources, they can interrupt program flow. And one of the coolest things about debuggers is you can actually modify code execution. So midway through running your program, you can change the course of the execution, the control flow. So what are your options? Do I really need to use a debugger? Well, your first option is only write or use bug-free code, okay? That's not my experience. Love it for you if that's your experience. What about print statements, huh? They're pretty handy. There can be like valid times to run if you know, for instance, if your code requires such a high level of optimization, and for some reason you can't add debug symbols, then printf could be your only option. But hopefully I'll convince you today that that is a bad option. So other reasons why it's bad is you need to recompile every time you add a different print statement. You could introduce new bugs. You know, maybe you think you've just added a print statement, and then just as you were saving, you pressed a button somewhere else, maybe undid another change, and you might have introduced a new bug. Want to see a new variable or print a new thing? Well, good luck. You've got to recompile again, okay, and rerun it and re-get to that point. Also, you can't interact at runtime, so you can't change the flow of the program like you can with a debugger. So, debuggers, you can interact at runtime, and I'm not explaining what exactly that is, but hopefully we'll come to see that later. But once you get into the debugger, you get access to the memory. And by access, you don't just get to read what's in the memory, but you also get to write to that. So all of your code is stored in memory, and you could say, oh, the variable x is no longer 5, it's 10. And that might mean your program goes down a different avenue, right? You can inspect everything, right? I don't know if anyone's worked with C++, but you might have some kind of class. It's got some private variables. It's got some public variables. If you're trying to print this print statements, you can only access public stuff outside of the class. Debuggers don't care. You've got access to all of the memory that your program has. You can see private variables no matter where you are in the code, which can be very handy. And you can use it for code exploration. I'm not going to cover that today, because I think we should learn how to use debuggers to debug first. But they can actually be really useful code exploration tools. And what I mean by that is, in my job, I'm a research software engineer. I work with many different groups, and they're like, hey, we've got this new code, and all of a sudden I need to get up to speed. I need to learn, what does this code do? Where does this thing run? And debuggers are great for them. So what are your debugging options? Well, there's GDB. That's the one we're going to look at today. There's other versions and derivatives of GDB. There's lldb, which is made by the Clang project, works with Clang compiled code. And then you've got things like IDE integrated things. You've got VSCode has a debugger integration, Eclipse, JetBrains. You can even add it to Vim, Emacs, etc. And then there's these like GUI wrapper programs. So you can get GDB GUI. There's one called Sear, and they're like applications that you run and you can debug the code in those. So we're going to learn today about GDB. That's going to form the basis of a lot of the exercises. But if you're familiar with another one, like let's say you use lldb in your spare time, you could just do the course with lldb, but obviously I won't be able to give you the commands for that. It's a command line debugger, and we'll come on to why that's important later. And it can debug programs written in C, C++, Fortran, Rust, and a couple of other languages I've never heard of, so I didn't put them in. Why terminals? Why do I like command line programs? Well, you've got this Unix philosophy, which is like, do one thing well, and it's extensible. So, you know, you can mix and match some of the Unix programs. So like for example, you can use cat and type, you can type that output to grep, right? With GDB, you can use shell commands, for instance, inside of it. And so it does this thing of it gives you a debugger, but it's also integrated. You can integrate it with other tools that you're familiar with. It's available pretty much everywhere. I couldn't tell you the last time I logged into an HPC system and it didn't have GDB. And anyway, you can install it if it's not there. It's free and open source. It normally comes packaged with the compiler. So if you've got GCC, it normally comes with the GNU compiler suite. It's scriptable. This is amazing. You can script your debug session. So just like, you know, you script your programs, you might make bash scripts, Python scripts. You can write a script to start your debugging session. And that can be really helpful, A, for reproducibility. So like, let's say you find a bug, you think you found a solution, you want to go show your supervisor. And then in front of your supervisor, you found all the keys, none of it works, and you don't know what you're doing. You can just use a script to get you right back to where you were. I mentioned earlier, it's extensible with other tools. Now, for most of this, well, all of this course, I don't assume really any prior knowledge about debuggers. I've tried an effort to make the codes like kind of simple, but I do need to give you just one bit of background information on what is a stack frame, because I'm going to talk about those in the context of debugging. So here on the left-hand side, I have a piece of code. It's like a C style, could be C++, you know, doesn't really matter. But it's a piece of code. And I just want to explain what the stack is and what stack frame is. So when we run, in this case, a C code, it will start at the main function. So the program will look for the main function, and that's where it will start execution. And when you run this program, so say / my program in your terminal, the operating system will allocate a portion of memory for your code to run. Okay, it will give you a stack, right? And every time, so this I'm going to be looking at is the call stack. So we're going to see what's going to happen in that in a minute. But as we initialize this kind of function and run it, it generates some storage onto the stack. And things are included. So you have a frame. So looking towards stack frames. This is a stack frame. And in it, it will contain some information about the function name. It will have the arguments. So if you notice, this function takes argc and argv. So it will have those available. It will also have storage space for local variables. So in this case, I've got two local variables, C and D. I might have more. I might have objects. It might be a pointer instead of an integer. But essentially, any kind of local variables can be stored on the stack. This is a very light version of what it actually does. It's actually, in practice, more complicated, and it's system dependent, architecture dependent. But this is the essence of what a single stack frame is. And it has something called a stack frame pointer, which is this, it's just an address that says, where does this function live in memory? Okay, and that will be important for later. So we run our program and we get to the line 15, and we have a function call, okay? And when we call that function, it creates a new stack frame, okay? And that stack frame has its own arguments, its own name, its own local variables. In this case, I've got a local variable called C. And I've done this deliberately. I've chosen the same name for a reason, right? They're all called int C, int C, int C. Because I wanted to point out the fact that these local variables are in separate areas of memory, that they're distinct versions. Although they have the same name, they have different memory locations. So this variable C, if I set this to 5, it doesn't affect this local variable here. Okay, so each frame has its own portion of memory, and you can have many frames. And if we keep going, eventually we're going to call function 2, which is nested in function 1. That creates its own stack frame. And then as we execute function 2, so we're now in function 2, when we get to the return statement, it needs to know where it came from so it can go back, right? And the way that it does that is it keeps a sort of address list of where it came from. So when it finishes, it's going to take this pointer and head back to it and then it will go back to function 1, and it will come to this point, line 10. So let's see that. We're going to go return. Then it returns, but it puts us after this function call. The next instruction is return again. We return from this one, and we clear the stack frame, and then we're back to here. We'd actually be back to the return 0 statement. And then finally, your program's going to exit, and it's going to delete the last frame. Okay, and you're going to free up the stack. If you generate too much storage on the stack, you'll hit a stack overflow. You may know the famous website, Stack Overflow. That's where that name comes from. Okay, so don't worry, we're not going to jump straight into exercises. I'm going to show you where the exercises are. But today we're going to be looking at a series of exercises that I've kind of made, again, to highlight types of bugs you would find in real codes, but they're heavily simplified. They're completely fake examples. They're not realistic codes. I think the goal of this is to figure, how do I use the debugger? Not how do I learn this random code that has some bug in it. So the goal is on the exercises. We're going to have about 40 minutes for the first 3 exercises. It's not a race. Like if you don't finish all the first exercise is the most important. It will teach you kind of all the fundamental commands of GDB, which is a serial debugger. Then there's going to be a couple of other examples in GDB. And then after about 40 minutes, we'll regather. I'm going to give you an introduction talk about a debugger that I make, which is called MDB, and that is for parallel programs. So anyone that was in the HPC session earlier and was looking at the MPI codes, once you get to parallel, much harder to debug. And I want to show you some examples of how we can debug that with MDB. So in the Slack channel, I sent a link to the GitHub. So if you could go to this website, well, there's different ways of doing it. I'll show you actually the VSCode approach first. Does anyone not have Visual Studio Code on their laptop? Does anyone not have Visual Studio Code? Raise your hand now or forever hold your peace. Super. Yeah, okay. So I'm going to use code, but I'll show you how to do it. You know how to use code spaces already, right? So I'm going to show everyone to do it in VS Code just because I find it a bit easy. Okay. So you can copy this link, the GitHub address. We're going to open Visual Studio, not in a directory, not with any files in it. We need to close this actually. Last minute stuff. Right, okay, so just open a plain Visual Studio Code, not in any specific directory. And what we're going to do is we're going to open a code space. So to do that, well, actually, so first of all, I'll show you that I've got instructions in case you don't want to follow along with me. But on the README, which you found at the link, if you go down, there's instructions for how to run it in Visual Studio Code and how to run it in your browser. I'm going to be following the instructions for running it in Studio Code, just because I find it easier. So what you'll need to do is go to the Extensions tab, which is down the bottom, and you'll need code spaces. So you can type code spaces, and it's called GitHub Code Spaces. So if you don't already have that, install it. I already have it installed. Again, in the README, I show you how to install it. If you've never installed it before, you'll need to log in. So I'll let you do that in a minute, but for now, I'm going to assume people may have used it before. So I'll just show you the next steps because I can't re-log in. And then anyone that gets stuck will be coming around to help you out. So I'm now going to go to Remote Explorer, which is the second one from the bottom. This might be a bit small, so let's see if we can. Okay, so this was the extensions list. Just above it, there's a kind of screen. This is called Remote Explorer. And if we go into here, we can copy the link, which is the, I don't want to copy the whole thing. Let's go to the README. We just want to copy, this. So go down to code, HTTPS, and copy this part here. I'll put it in, I might put it in the Slack channel actually, so it's easier. This is what you want to copy. If we go back to the code spaces, we can search for that. It's embarrassing me in front of my friends today. I'll tell you what, Let's just delete the front bit. Oh, it's the full stop. Oh, it's not happy, is it? Oh, that's why. Sorry, I didn't click create code space. My bad. Click create code space, copy the repo, hit enter. It will ask you what branch you want to build the code space on. We want to build it on main. There's only one choice anyway. And then it will also ask you, do you want 2 cores or 4 cores? We're going to need 2 for this. We don't need 4. So this will take, the first time you run it, about five or so minutes to set up. So get started with that. Once everyone's got it loaded, I'll show you where the first exercise is, okay? So whilst everyone's code spaces are loading, if you want to focus at the front, I'll show you kind of where the first exercise is, and I'll walk through the kind of starting procedure of that. And let's make this a bit smaller. So the way the repository is structured is there's a README in the main root directory. And if you look at the READMEs, every exercise, so there's 4 exercises today. In the first half, we're going to look at exercises 1, 2, and 3. And then in the second half, after I do another short talk, we can then take a look at exercise 4. So to get to the first exercise, we can navigate to this folder and click on the README. Okay, and this is going to be the first exercise we're going to do. Then there's one more bit of information that we need. We're going to need, so this is our README, this is our guide for the session, but then we also need a terminal. There's different ways to get a terminal. I think it's Control Shift Backtick gives you a terminal, or there's probably a button somewhere that I can't see because of this thing. Probably like terminal, new terminal. So you can either get it from, because I'm zoomed in, it's not easy to see, but along the top, there'll be a button that says terminal, and you can do a new terminal, okay? We don't need the ports, so you can fold that away. And I made 2 new terminals, so I'll just get the one, okay? And this lesson, on your laptops, you won't be as zoomed in as me, so hopefully you'll be able to see the instructions as you go, and you'll be able to see the terminal, okay? I've designed this kind of lesson so that you can study it in your own time, so we can do it like together, but no one has to kind of like go at the pace of the fastest person. So there's lesson objectives. There's a bit of a description about what the first exercise is. Like I said, it's going to be to learn how to use GDB. And with every exercise, I provided a C++ and a Fortran version, in case you're more familiar with C or Fortran, right? Or C++ or Fortran. So for exercise 1, there's a file called play.cpp, or there's one called play.f90. If we go to the terminal, so I open the terminal, I need to CD, because by default, it will start at the root directory. So we need to CD into the exercises. And then we need to go into exercise 1, which is called exercise 1_play. So I CD into that, and then I press make. What this will do is it will build both the examples, the Fortran and the C++. And you can see that there's one called play.cpp, and there's another one called play f90.exe. So let's try and follow along with the course. Let's open the README. I'm honestly not sure what view is better. Can people read this at the back? Yeah, a very, very small. Okay, I'll split it into 2 windows and make it bigger. Give me 1 second. There's one of these buttons pops it out, and I don't know which one it is. Does anyone know how to use VS Code better than me? I know there's a button to take this terminal out. I just don't know what it is. You can pop it somehow. Don't bother me. Yeah. Yeah, honestly, like I literally did this on my computer when I was testing, and it's like it doesn't, maybe I did an update and it's not there anymore. Anyway, on your screens, this will be easier to read. I'm just gonna have to make this full screen. So we're gonna do the first exercise, and I'll have to shrink the terminal for now. So the first exercise is all going to be about, we've built the code, now we want to debug it, okay? So to debug it, we can just follow the commands in the README. We're going to type gdb /play, and that's going to be the command that we're going to run. So if I copy that and go to the terminal, and just paste that and run it. This is going to put us into the debugger, okay? Then we just keep going through the exercise. We can start the debugger. We can start having a look at variables. But I think it's, well, we'll see. I think if we start people going through it, and then if people get stuck on the same things, I'll regroup and I'll show you the first exercise. But it's kind of easier probably to see it on your own. Has anyone not got the code space set up? I guess I want to make sure that everyone can at least run make and then run GDB. So has anyone not got this far to GDB? If you haven't, just put your hand up and we'll come around and get started. It's strange. It's just not there anymore. Yeah, have a look, see if you can find it, because I did it literally the other day, but then I updated VSCode. Yeah. And I've done it, like it was working. I think it's an update, and then it's also
Yeah, actually, I just did that online, which is sort of like, oh, maybe they'll be moving.
there we go.
Okay.
Super, thank you. Didn't realize we'd have the world's one of those, for instance. We have a very small screen, no real estate. So just a quick announcement. If anyone is going to do the Fortran examples and you would like some syntax highlighting, which is makes perfect sense. So currently, if you open a Fortran file, it will look very vanilla. So if you go to your extensions, you can install the modern Fortran. Now, by default, due to how code spaces work, you can't install unverified, unsigned, un-Microsoft packages automatically. Okay, so even if you add it to the code space configuration, it won't install it. And for people like myself, and I think Victoria at the back, if you've already installed it on your laptop, it's even more confusing. So give it locally. When you try and install it, it sometimes doesn't let you. I need to shrink this a bit. So why am I installed? So I think sometimes when you click this button, even if you click it install inside this thing, it doesn't always work. So it says signature failed, blah, 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 blah. This is a bug in VS Code. If you click the wheel, there's an option to install, or somewhere there's the option to install a specific version. Again, I think mine's just changed. Install, yeah, so this makes no sense. I didn't write VS Code. Under uninstall, there's a button, which is drop down. If you click it, it says install specific version. Now that's very small. Let me make that bigger. Okay, now let me shrink this, make this bigger. So the drop down next to uninstall, if you click that, install specific version, the latest one, it should then work. It's loading, but it should then work. And we can go back and check our code. So let's have a look. Not done it yet. I might have to even uninstall it and reinstall it again. Let me know if that works for you, Victoria, because otherwise I'll just uninstall it and reinstall it. Does it work? It works for you. Not for me. But if anyone else is doing Fortran, just try that if you haven't. Yeah. It's very bad. There we go. Install anyway. Yeah. Hopefully it will work better on yours than on mine. So at the end of every exercise, there's a kind of final bit of that exercise where you can practice out your own things. It's up to you. You can either do that or you can move on to the next exercise. This is all on GitHub. You can get the code space anytime. So if you want to, it's up to you if you want to invest all the time into exercise one. In about another 20, probably 15 minutes, I'll be stopping so I can tell you about the MPI codes. Okay, everyone, I think now's a good time because I want to see if anyone's got questions, and a couple of things have been raised, and then it will give me time to give a bit of a talk on the parallel debugger, which is very similar to the serial case, but we have now multiple processes. So how, it's the free text form, but maybe, I don't know, like we've all got 5 fingers. So can everyone kind of give a 1 to 5 rating on how they found that in terms of how easy is it to follow along from 1 to 5? 5 is very easy to follow, and one is like not easy to follow. Okay, nice. That's good. I'm doing some maths in my head. We've got like a 4.999. So yeah, any feedback, if you want to speak to me at the end, if there's things that like you think could be better, it's a bit different. Normally I just talk at people for ages and show them, like demo it myself, but I think you learn so much more by doing it yourself. So it feels eerily quiet in here, but I hope that means everyone's like brains are churning. I can see steam rising from foreheads, so it's good. Right, just a few little things. So I was going around and someone asked about this, so let me first open it in the text editor. I'm going to deliberately make my terminal small so that we get the effect. cd into exercise 1, make, and I'll make it even smaller. So when we run GDB, this can happen many, many times. So I'm going to run it in quiet mode, and I'm going to run one of the examples. It doesn't matter which one. Okay, so I'm in GDB, and this is very small. Let me make that bigger. And that's too big. Okay, so I'm in GDB, and let's say I do a command like help start. Not that one. I don't know, help break. Okay, can you see at the bottom of the screen, it says type return for more, Q for quit, or C to continue without paging. So GDB is a terminal-based application, and way back when, terminals weren't that big, screens weren't that big, and so if you have a program and it outputs loads of text, you may not have even been able to scroll back and see what that text was. And so pages, things like less, more, and in this case, GDB has its own pager, it takes a chunk of that output, it fills a page and it prints it, okay? And it says, are you ready for the next chunk? And then you'd say, you can type enter, and it will give you the next chunk. And you can keep doing that until it finishes paging it. But on modern terminals, modern screens, it's not really a problem. You could just say C, and you can do that, and then it will continue without prompting you every time. That can be also quite annoying. GDB has a configuration file. It's called the GDB init. And in that, you can do things like set pagination off. So if you use this command, set pagination off, it basically says, stop asking me if you want to page the output. I don't care. And then when you do help a command, it will print it all, and you can scroll up and you can see the information, okay? So if that bothers you and you find it really annoying, you can create a file in your home space. I keep trying to use Vim, it's not installed. I just need to do a new file. So new file, and we'll do set pagination off. And you would save that and call it .gdb init. I don't even know how to do that here because I don't know how to access my home in this code space. Set pagination off, .gdb init, and you could save it. And then the next time you start GDB, it will load that setting, and you should be able to do, this may not work because I don't know if that's in the home folder. You should be able to do help break and it won't ask you. In this case, I've put it in home space. On your local laptops, that will work. All right, did anyone have any questions from the first exercise? First exercise is however far you got. Any questions that were raised? No? I'll just step over a function. So if you do next, like it won't step into that function. So yeah, so when unless you, yeah, so if you type step, it steps into a function. If you just type next, it will stay at the top level and just do the next like instruction in that level. However, there are exceptions. If you set a breakpoint in a function and try to step over it, GDB will drop you in the breakpoint. Yeah. Okay, so I hope you found the first set of exercises useful. It's essential that you understand the bits in exercise 1 before I start talking about parallel debuggers, which is a whole nother world. So I want to tell you a bit about MDB, which is a parallel debugger. It's so it borrows the name from GDB, except instead of serial programs, it runs for MPI programs. And so that's where the M comes from. So got a few things to show you now. So skip to that. Here we go. So a little bit of information about MDB. It's a tool that I am the lead author of, or like create or whatever. It was a kind of a pet project that's now actually become useful. I work a lot with weather models, climate models. On today's HPC, if you were in the HPC course earlier, the only way you can the main programming paradigm to program distributed supercomputers is to use MPI. So if you're going to be running climate codes, weather models, nuclear fusion codes, quantum chemistry codes, any kind of fluid dynamics, you're going to need to know MPI. You're going to work with MPI codes, and they're going to have bugs in. So knowing how to debug them is going to be very useful. This is kind of my approach to it. I made this tool, obviously I'm plugging it, but there are other options available that you can look at, but there's not really any good open source free ones. So it's terminal based, just like GDB. You can use multiple backends. So we didn't cover this, but you can use lldb, you can use CUDA GDB. There's all these kind of different backends you can use. You can use Rust GDB. Under the hood, it uses Python's asynchronous library to do the communications. There's some commands which are called holistic commands that will run on all of the processes and gather that data for you. So kind of like reduction operator. But you can do plots and you can dump memory. It's also scriptable like GDB, and that's deliberate. I really like the fact that you can script something. You could add, like, I was working with a colleague on a weather code that had a bug, and we scripted the session, and I could send him the script and say, I'll run this and tell me what you get. And then I can help debug remotely, or like we could also save our progress and then share it with someone else. So it's very handy. And it's almost essential for MPI codes, and I'll get into that a bit later. It's free and open source, and it's like pip installable, spec installable, UV installable. It's probably other things installable, not Conda, I'm too lazy. But yeah, and then there's a QR code, it's on my GitHub, I'm going to come out MDB. But it's already installed in the code space, so you don't need to do anything, it's already there for you. Okay, I want to show a little bit, just so you understand how it works in the background. You're not going to get tested on this, and it may not even be legible at the back, right? I can't make this any bigger, I'm afraid. But the way that it works is it has kind of two main commands you can think of. You first launch it somewhere. So again, from the HPC course we did earlier, when you actually run your code, climate simulation, fluid dynamics, that can't run on the login node. Okay, you've got to run it on a compute node. And those compute nodes are separate. So you launch it on a compute node, and then later on, we're going to attach to it from the login node, from your laptop, from whatever. Okay. And I'll show you how to do that in a minute. So what does launch do? Well, first of all, it wraps around this MPI run that we saw earlier, or MPI exec. It will actually launch. If we say, oh, we want to run a program with 12 processes, it will get to here and it will launch 12 instances of GDB, one for each process. Each of these is wrapped by a little kind of Python scripting by me, which then basically connects to a server somewhere. And that, well, not somewhere, a server running on that machine. And that server is how we're going to interact with it. So we're going to connect to that and send commands and say like, oh, the user wants to print variable X. And then each process will get that, print it, and give it back. Okay. So in order to give commands to the debugger, we need to attach to it. And that'll be the second stage. When we attach to the Exchange server, and then we can start issuing commands. So I could say, I'll set a breakpoint on line 10. And the key thing with MPI to remember is MPI's programming model is it runs n independent copies of a binary, right? So each one is running exactly the same code, but with a different rank. So rank 1, rank 2, rank 3. And so you can say set a breakpoint, and all of them will set a breakpoint in that place. Right? And I'll show you the examples, but you don't have to do all the same thing. You can set different breakpoints. That's going to be enough of the background on how MDB works. I'll start showing you the beginning bit of the exercise, how to set it up, and then you've got about half an hour to play with it. I'd encourage you probably, as long as you've done like half of exercise 1, you know how to start, set a breakpoint, and do next. You can just move on to the MPI one and just do those things in an MPI program. You won't probably be able to solve the bugs, but you can follow along and just have a play and see what it looks like. So I will show you. Oh, go on. Yes, questions. Depends. Choice of the user. This is going to be one of the most crucial things. So let's go into the README so I can start things. No, you do. Well, it's a great question. So let's go into it. So we've got exercise 4 we want. Let's go into this stuff. So we're going to go into exercise 4. So if you're in your terminal, you'll need to do CD, go back a directory, and then you'll need to CD into exercise 4. Okay. and you can just run make, and that will build the codes. Again, I've configured everything for you in this environment. So this code space has MPI installed, has MDB installed, and it has a couple other utility things, and it's all set up. But most HPC systems will have some installation of MPI. And if you're on Linux, you can install it through your package manager quite easily. But this code space, like I said, it's always available. You can play with it anytime. You can load it in your browser in codes in VS Code. So it's not like after today, or after this week, you can't do these exercises. You can do them anytime. Okay, so we're going to open our the README. We'll open the README for this exercise. So I have to do a bit of screen management here because there's not enough real estate. So one of the crucial things about debugging MPI codes is you kind of need to think in parallel as well, okay? There's nothing special about the debugger. Like I showed you how I launch it. You basically launch n separate copies of the debugger. This is where you need to have an understanding of the code somewhat. Unlike with the serial code where you can just throw it into the debugger and be like, run my code, do this. When you get to parallel programs, there are differences that you kind of then need to start to be aware of. So for instance, if one process loads a file, but none of the others do, and you tell all processes, oh, I want you to set a breakpoint when you load in a file. Well, the first process will stop at that breakpoint, but the others never get it. And you'll just be left waiting in the terminal while your debugger's hanging. You'll be like, oh, this is rubbish, it doesn't work. Unfortunately, I don't know a way around that. Like, there's nothing we can tell the debugger about the MPI code about what's going to happen in runtime. So unfortunately, like learning how to debug MPI programs is also a lesson in understanding how parallel code executes. Like, there's no other way around. The same way that if you were writing the code, you'd need to have an understanding about these kinds of things. But MPI debuggers can help. Okay, you don't need to know everything. They're not, but you need to know some stuff. And you'll see that in these examples. When we start following the examples, you'll see like when you need to do certain things differently. And I'll show you how MDB can do that. So again, in your own time, I'll let you read the background of this code. Again, it's a toy code that looks at processing some data. So each rank loads part of the file, and then you're going to process it separately on each rank, and then we're going to kind of gather that together. So it's kind of a very typical use for MPI. So let's get down to it. So I want to show you how to launch the debugger and how to attach to it, and then you should be okay to just jump in and try and play with the exercises. But I think sometimes there's confusion around this stage, so let's do that together. So I'm going to open my terminal. So let's pop it out. 1 second. Oh my goodness, I've already forgotten how I did this. New terminal into edit area. Well, that's nice. Not what I want. Okay. Right, there we go. I've now got it in here, so this will be a bit easier to read. Okay, so I've already run make, and I've got analysis, CPP, Fortran 90, just like we had before. Whatever language you prefer, feel free. So we need 2 terminals, actually. We're going to need 1 terminal to run the launch command and 1 terminal to run the attach command. Now, in reality, on a HPC system, you might be running the launch command in a submission script, and then you'd attach to it from the compute node, from the login node. So we're going to run MDB launch. There's a couple of things I wanted to show you is like, how can you get help with MDB? Well, I've gone to some lengths to add help information so that you can type -- help, like you would expect with other command line applications. I also have documentation. So if you go to the GitHub page, there is a link. Well, that's not MDB though. If I go GitHub, and we'll search for MDB. So if you go to MDB's website, or the GitHub page, sorry, there's a link to documentation. And there is a read the docs. So you can look at a quick start guide. There's information on the API, blah, blah, blah. Like there's probably an information overload. But I just want to say that it is out there in case you want to look at it in your own time. So we want to launch an MDB. MDB launch. Just like with MPI run, you need to specify how many ranks you want to run on. This is a free GitHub tier, and we all launched it with 2 cores, so we don't want to overload it. I configured it to allow up to 4 for the purposes of this demo. So you can do MDB launch -N4, but if you're running your AI weather code or whatever, and you need more, you just change that number. Then, as I mentioned, a debugger debugs a target program, so we need to specify the target, which is -T, and then we can say analysis, and then I'm going to pick the Fortran one. It literally doesn't matter, whichever one you prefer. Oh, one more thing I need to do. I should show you the error, actually. By default, when I wrote MDB, I used port 2000 because it was free on my laptop. Like they're arbitrary, right? I've since learned that CodeSpaces uses that port by default. So we need to pick a different number, okay? So I'll show you how to do that. So MDB -N4 -T your program, and then -P to set the port. You can do -- port as well. And we're just going to pick 3000 because that is free. You could put any. The larger the number, the more likely it is to be free. I think the lower numbers below 10,000 are reserved, not reserved, but like more common than these. Who cares? Right, so we've launched that. Now we need to attach to it. So we're going to get a separate terminal. And I need to go into the directory. I don't need to go into the directory actually, but I want to because it will make the rest of the exercises easier. So I'm going to go into that directory and I'm going to do MDB attach. And I may not know how to use that. So again, there's a help for this, and it shows you how to use it. The only thing we need to specify in this, and well, let me show you. Let me show you another way. Exercise 4. So you might notice that when we launched this, what it does is it spins up a server, and now it's waiting for us to attach to it. And the way that we can attach is it kindly tells us, hey, if you connect to this debugger, run this command. Attach, it gives you the address IP for the machine you're running on, and then it also gives you the port number that you specified. So this, if you run this from another machine, like from the login node, for example, on that machine, you'll be able to connect to the compute node. That's kind of the way I designed it. And because we're running it locally on these, locally on a remote code VM, it's all on the same machine, and this is localhost. The 127.0.0.1. So that's just telling it to use the local network. Okay, so let's copy paste this. And we're going to go into our other terminal. So I'm going to copy paste, Control-Shift-C when you're in the terminal. And then I'm going to paste it Control-Shift-V. And I'm in the same directory. You don't need to be, but it will make the later bit of the exercises easier. And now I'm in. Okay, and it's a bit like GDB, and that's by design because I wanted it to feel familiar for people who have experience with serial debuggers. And I can start to do the same things. However, again, now we have 4 processes running, not just one. So if I want to send commands, there's different ways to do that. I have a command called command, which is a bit of a mouthful, and I now regret that choice. But the command will send, oh, so horrible, send commands to the processes. So I could say, send it to process 1 and 3. And I could say like, start, for example, right? And then it would just send that to 1 and 3. I could then say 0 and 4, like 0 and 2, sorry. I could do like set a breakpoint, right? So I could do break on line 10, for example, or whatever, right? You'll notice that you didn't break on line 10, it broke on line 20. And if I show you the code, you'll see why. So if I did something like command, there it is, do it a couple of times. Line 20 is not executable code. So the first line it can set a breakpoint is on line 26 or something. Anyway, that's how to get connected. Once you're connected, follow along with the README. So I showed you the first steps, MDB launch. I showed you how to attach. I want you to now have a play and see what it's like doing parallel code versus serial code. Any questions, just put your hands up. The question. It's written in the README, but I might have skipped that. So the question was, when you're looking at the output, how do you know which output comes from which rank? And again, by design, I did this very deliberately. But if I do something like, so this is going to run on all of the processes. So I need to make it a bit smaller so it fits on one screen. But just here, at the front of every bit of output, there's a number. You've got 0, 1, 2, 3. This is the rank that it ran on. And they're separated by these kind of stars, right? So if I do command 1 and 3, and then do a small command, you'll notice that it's only 1 of 3, okay? The other deliberate thing I do that MPI doesn't guarantee is I always sort the output. So normally when you run MPI programs, there's no guarantee on the ordering of the output. So another great use for MDB is sometimes you just want to know what ranks output and what. There are other ways to do it, but it's quite nice that it sorts all the output for you. Okay. Thank you for the question. Okay. I'd like to wrap up now because I want to ask some questions from the audience. So yeah, I hope everyone has had some fun debugging, and then we can all agree that parallel debugging is like parallel fun, right? It's like n times more fun. So a couple of questions. Well, first of all, does anyone have any questions for me about any of the material today? Any questions in general? So I had a question for you, which is comparing this to other types of tutorial you might have been to, do you like having all the material and just being able to go through it in your own time? Or would you prefer something more interactive where I go through the examples in front of you? So maybe if we do, who would prefer more interactive that I go through it and talk you through them? And who, yeah, got one. Who prefers having all the material and just doing it themselves? Okay, that's nice. And then who has another opinion that I haven't thought of that's also equally great? Is there another option that I haven't thought of? No? Okay. It feels uncomfortable for me because I'm like, I hope people are liking it and it's going okay, but there's less feedback. So I think I might try and think of another way to get that as well. Well, yeah, I mean, you've got all of the material now, so you can play through it in your own time. Any questions with the material, any issues, you can either raise an issue on GitHub, or you can send me an email or contact me on the Slack channel, Slack channel. But yeah, I think that's going to bring us to a close. There's nothing else that I can think of to cover. I'll just go back to my slides and summarize. So hopefully today we've learned a little bit about scripting debug sessions. I appreciate not everyone had the chance to get to that. So if you didn't get to that, trust me, it's awesome. It'll be really useful. Again, there was the handling implement loop, which is exercise 2. If you haven't had a chance to look at that, take a look at that in your spare time, because I've hit this many times in my career that a code gets stuck hanging forever. And you're like, why? Where is it? So there's exercises on that. And we've learned how to debug MPI programs. I mentioned earlier that debuggers aren't just for bugs. So I recently started a project with a very large code called CSM, which is a community assisted model. I have no idea. I've never written a line of code for it. And then all of a sudden I have to add like bits into it. There's 1 million lines of code and like 5,000 or 15,000 source files. So like if you want to try and find that kind of needle in the haystack by reading every line of source code, you're going to be there all year. Debuggers are great for code discovery because I can set a breakpoint and say like, stop here. And then I can say, how did you get here? So in the first exercise, I think it covers backtrace, which tells you where you are in that stack frame. It tells you where you came from. So you can find out if there's a function, let's say like compute gradient or whatever, and you don't know where that gets called from, and it's like deeply nested, you can find exactly where you came from. and you can go backwards and find out where you are in the code. So they're really, really useful for code discovery. And yeah, that's everything I had. Thank you so much for listening. Thanks for taking part in the exercises. Feel free to contact me if you get any questions.